Folks, I'm going to solve one more problem in this unit, which is 216, problem 216. If you look at this problem 216, the application is here, is a product mix problem. Okay, so the problem is Nutrigen is a weight management center. It produces a wide variety of frozen entrees for consumption by its clients. The entrees are strictly monitored for nutritional content to ensure that the clients are eating a balanced diet. One new entree will be a beef sirloin tips dinner. It will consist of beef tips and gravy plus some combination of peas, carrot, and dinner roll. So Nutrigen would like to determine what quantity of each item to include in the entree to meet the nutritional requirements, while costing as little as possible. So that means what we have to do is, what is the amount of beef, gravy, peas, carrots, and rolls we want to have as a combination that's going to get them the nutrients that they want, stay within the calories and get the units of vitamins A, C, and protein. Okay, so how much they need. Okay, so that information is given here. Okay, they need at least 600 IUs of vitamin A, 10 units of vitamin C, and 30 units of protein C, and at least 280 calories total calories, and not more than 320 calories. Okay, and also it says that the problem requirement is the total fat calories that you get from the fat should be no more than 30% of the total calories, so that you receive from this combination. So if you want to find out what is the best combination of this ingredient, of this entrees that we want to put together so that we meet the nutritional requirements and at the same time keep the cost to the low. And if you look at it, the application is hospitals, nursing homes, and any caring facility that you can think of, the school and other areas. And believe it or not, so this area of application is fairly wide, and the consequences are pretty serious, either to the patient's health in terms of the nutrients being supplied to them in proper quantities or not, and at the same time to the business unit itself in terms of the total cost of meeting those the nutritional requirement the patient or the school children they need. Or it could be a feed mix problem for the agricultural industry. The same thing. Replace the people with the animals like cows, horses, dogs, and pigs and others, and you have another situation. Okay. Now I have laid out. So again, the decision variables are how many ounces of beef to use and gravy, peas, carrots, and rolls to use, given that each ounce of beef contains 54 calories and 19 calories of those are from the fat. It doesn't contain any vitamin A or C, but it contains 8 units of protein. On the other hand, if you look at carrot costs you 18 cents, per ounce, per ounce. And you get 8 calories, none from the fat. You get 350 units of vitamin A and 1 unit of vitamin C and 1 unit of protein from there. So each one of these ingredients has different combinations. Okay, now as before, let's go and get the relationships. Again, the amount of cost that you incur depends upon the amount of these ingredients that you use, and their individual unit cost. Okay. And again, I have highlighted in yellow the decision variables and the things that get computed in gray. Okay. Now, the total calories that you get from this combination that we determine. So A is nothing but the total calories. So here to the right, I have basically labeled what that stands for. That's the total calories. Again, depends upon that. Sum product the number of resources that we use. And again, on your keyboard, you hit F4 to make this absolute reference. Okay, on my keyboard, which is a different kind here, somehow that function is not operational, so I'm just going to prefix them with a $sign. Okay. Okay, so that's one way to do it. Or on the other hand, what I could do also is, since I showed you this is the one that's going to be common, and I'm prefixing that with a $sign. Okay, I could maybe take a shortcut and use a range name. Okay, let me do that. Okay, let me do that, and it's going to be the common. And before that, I need to define this range. Let me go and then define that range and just see where my cursor is and call that decision. And now over here, this range is now given a name, decision. I can highlight that, or I can just go and do the sum product. Now I can just type decision. Got to just make sure that you don't misspell it. The spellings are same all the time. That's one thing. So the amount that I basically use, that's my decision times the individual contribution. Okay, is what it is. Okay. And now I can just go and then copy the command all the way down. Anytime that you copy any formula, just go in any of those places where you copied the formula to and go double click and see whether it is picking up the right information. Yeah, for vitamin C, what is the total vitamin C that you would get from this combination of the ingredients? Okay, how much am I going to be using this times whatever the individual contribution gives me the total? Yes, it is done right. Okay, now we have a spreadsheet model in which we have the total cost as the amount that we use times their individual, the pricing, and the total calories that we would get from using this combination is given here, and the fat calories here, total vitamin A, total vitamin C, total protein. Okay, now we have certain restrictions. We want to make sure that the total calories that we consume as a result of the numbers that we get, okay, that the solver is going to compute for that what's the best combination. So that total calories should stay between 280 and 320 min and max, and the total fat calories that we get should be no more than 30% of the total calories. The total calories would be written here, so we want to get a relationship between these two. Then the total vitamin A here should at least be 600, total vitamin C should at least be 10, and total protein should at least be 30. And in addition to that, it also says at least you should use 2 ounces of beef, and also there is another restriction when you read the problem. The gravy should at least be, you got to use at least, for practical reasons, it must include at least 2 ounces of beef, and it must have at least half an ounce of gravy per ounce of beef. Okay, so that's that restriction. We need to now pass all this information to this spreadsheet, to the solver. Go highlight, make this cell my target, click on data, click on solver. Let me bring it down close there. My target is not to maximize my price, but to minimize. Check on that one. Okay. And my decision is, now you can type in the decision, or you can just go and then highlight that one and save. I could type in decision here. That's fine. It still is going to pick up that information. Add the constraint. The constraint is now this total calories, refer to the problem. The total calories that we end up getting, okay, from there should be less than or equal to the maximum. That's one. Okay, we are not yet done with all the constraints. We took care of one. Add, go to the second constraint. That again says the total calories that you get should be at least, that is greater than or equal to the minimum. We got the second restriction. Add, Go to the third one. The total fat calories that you get should be no more than. So that is less than or equal to 30%. 30% is 0.3 times the total calories. So this is where we compute total calories. It should be less than or equal to 0.3 times item. So you can do this kind of multiplication, that processing you can do. So we took care of that total fat. Now all these three, the vitamin A, C and protein, are at least greater than or equal to, so I can pass them as one block. The total vitamin A, vitamin C and protein should be greater than or equal to, the right side is 600, 10 and 30. Now I can pass that as one block because they are all greater than or equal to. At the constraint, the amount of beef, this is where we are going to compute how much the amount of beef we are going to be using. Okay, the amount of beef should be at least, so that is greater than or equal to 2 ounces. Okay, add one more. Also it says it must include 2 ounces of beef. We did that. Must have at least half an ounce of gravy per ounce of beef. At least half an ounce of gravy. So this is the amount of gravy. That's where it is. Should be at least that is greater than or equal to half an ounce. Okay. It should be at least half an ounce of gravy per ounce of beef. So 0.5 times the amount of beef is that cell. Okay. So in other words, if I go for 2 ounces, of beef, let's say 2 times 0.5 is 1. So I will have 1 ounce. So my gravy should at least be equal to 1 ounce. That's what it says, half of that. Okay, so that's what it is. If I go for 4 ounces of beef, then 4 times 0.5 is 2. So the amount of gravy should at least be 2 ounces. So half of that. So that's what we got in there. Okay, now we passed all the information. Click OK. Click Options. And of course, linear relationship, assume non-negative. You have to check all this all the time, these two. Click OK and solve. And you get the answer. Solver found a solution. All constraints and conditions are satisfied. Now if you look at the recommendation, what do we get? It says use 2.936 ounce of beef, add 1.47 ounce of gravy. You know, that's just little over half, just about half of that, as you could see. Then 3.11 ounce of peas, 1.58 ounce of carrots, 1.82 ounce of rolls, for a total cost of $2.62. You are going to provide 320 calories, total calories, and out of those 96 calories are from total fat, and this 96, if you see, is less than 30% of, okay, less than 30% of 320. See, no, not exactly. It's not less than, it's exactly. See, 0.3 times 320 is 96. That's what it is. So we are keeping the total fat calories to minimum, and we are keeping the total calories to maximum, and we are getting exactly 600 units of vitamin A. That's what is required. You are getting 12.4 units of vitamin C, greater than 10. Then you are getting exactly 30 units of protein. That's what it is. And now you got to use at least 2 ounces of beef. We are using 2.936. At least half of that ratio should be the gravy, and we are getting exactly half that ratio, and that solves this problem. Now, as you see, the layout of this problem was slightly different than the one that I did. So in other words, there is no one format. So it is all going to be very individual. Okay, it's all going to be individual. It all depends upon, your style and then how you want your spreadsheet to look like.